Hi everybody, welcome to day 5 of our 100-day basic solar training. Today, I'll be talking about common terms in solar energy. Alright, watts and kilowatts, volt amps and kilovolt amps, power factor and kilowatt hour. Number 1, watts and kilowatts. You will see systems rated in 100 watt, 200 watt, 300 watt, and the likes. So what is watt? Alright, watt is the unit of power. A kilowatt is 1000 watt. When we say 1 kilowatt, it means that 1000 units of power. It is also called real power. Kilowatt is the amount of power that is converted into useful output. When we say this inverter is 10 kilowatts, it means that that inverter can output 10 kilowatts of energy. Alright, you see, kilowatt is the amount of power that is converted into useful output. Kilowatt is therefore known as actual power or working power. So what then is volt amps and kilovolt amps? Alright, what then is kVA? Also called apparent power, a term used for rating electrical circuit. kVA is a product of the circuit minimum current. Note that the minimum current and the voltage ratings, alright, tell you the total amount of power in a system. For example, you can see an inverter rated 10 kVA or 20 kVA, alright, but that doesn't mean that you can use the whole 10 kVA in that system. Alright, you will check for the power factor. Is the power factor 0.7? Is the power factor 0.8? Is the power factor 0.9 or 0.95? Alright, but an ideal system will have a power factor that is equal to 1, but not all system has an output or has a power factor that is equal to 1. However, the closer the system is to 1, alright, determines the efficiency. Okay, now let's now move to power factor, because power factor is very important. I know some systems now that they have put some power factor corrections to make the system more ideal, to make the conversion efficient. Alright, power factor, you can convert between kVA and kilowatts if you know the efficiency of the system. For example, you see an inverter, but let's just say this: most hybrid inverter has a power factor of 1. Alright, it is 6 kilowatts. Alright, so if you see an inverter that is 10 kilowatts but the power factor is 0.8, alright, just multiply 10,000 times 0.8 to give you 8,000. It means the efficiency of that inverter is 80% or 0.8. Are you following? So you can convert between kVA and kilowatts if you know the efficiency of the electrical system. Electrical efficiency is expressed as power factor between 0 and 1. Power factor is between 0 and 1. Alright, the closer the power factor is to 1, the more efficiency the kVA is being converted into useful kilowatts. Kilowatt, as we explained earlier, that is the actual power or the working power. Generators has a power factor of 0.8. It means it has an efficiency of 80%. Now let me explain this. The formula of converting kVA to kilowatt is apparent power, that's kVA, times power factor. Alright, if you have, let's say, a 20 kVA system, alright, and a power factor is 0.8, but as we have it here, 100 kVA generator or 100 kVA inverter times 0.8 power factor, that will give you 80 kilowatts. That means you can only use 80 kilowatts from that system. That means the actual power or useful power or working power in this 100 kVA system is 80 kilowatts. Alright, now the formula for converting kilowatt into kVA is also simple. Alright, so you take the actual power in kilowatts divided by the power factor. Alright, you now get the apparent power. So we have it here, 100 kilowatt divided by 0.8, we have 125 kVA. Now lastly, I will explain kilowatt hour. Kilowatt hour means a measure of electrical energy equivalent to power consumption of 1000 watts for 1 hour. You see the discos charge you probably, if you're on band A, probably 200 naira per kilowatt hour. Alright, so it means that what you will charge 200 naira if you use a load or energy of 1000 watts for 1 hour. But now to battery system. Battery are also rated in kilowatt hour. All right, 5 kilowatt hour, 10 kilowatt hour. It means that what the amount of energy that battery can dispense if you put a load on it. All right, let's assume you have a load of 1000 watts on an inverter. All right, and you have a battery of 5000 watts. Let's assume the depth of discharge is, let's say, 100%. Let's say 100%. It means that you can take the 5000 watts divided by the 1000 watts. That means you can use that battery for 5 hours. Okay, so on the next day, tomorrow, we'll explain more of the times we have or the times we use in solar energy. And this brings us to the end of day 5 of our basic solar energy training. See you on the next one. Thank you. Bye.